Imagine a landscape sculpted not by nature, but by an audacious human will. A shimmering expanse of water, once a natural bay, transformed into solid ground. This is Qatar, where ambition reshaped geography itself, literally vacuuming the seabed and stacking it into a new dry landmass spanning 38 square kilometers. Upon this artificial foundation, a vision emerged, in a Qatari coin. This architectural marvel, destined to pierce the sky at 211 meters, presented an engineering paradox. Every expert consulted declared it an impossibility. Yet the blueprint called for a structure where no two floor plates would be identical. A dizzying spiral of unique geometries. 8 massive concrete core walls were designed to carry the entire immense weight. But each section of the building would behave differently under the relentless forces of gravity and wind. The load path became an intricate ballet of stresses, a single miscalculation threatening catastrophic failure. The sheer audacity of the project demanded a pause, a moment of reckoning. Before a single pile could be driven, the true nature of the ground beneath had to be understood. What they found was a treacherous mix. The top 20 meters comprised lug capacity. It was incapable of supporting even a fraction of the immense weight of the proposed skyscrapers. The SPT blow counts, a critical measure of soil density, registered alarmingly low near the surface. It was a foundation of quicksand, waiting to swallow any structure whole. Only a deep, ancient layer of hard rock offered any hope of salvation. This revelation demanded an unprecedented solution. Engineers conceived a network of 2,067 bored piles, each a meter wide, the diameter of a large industrial barrel. These massive columns would be drilled 35 meters deep, straight through the unstable reclaimed soil, anchoring firmly into the bedrock below. Each borehole, a precise cylinder descending into the earth, required a constant flow of bentonite slurry, a viscous liquid, to prevent its walls from collapsing before the concrete could be poured. This unseen fluid was the silent hero, holding the very ground in place. Into each of these subterranean shafts, a colossal rebar cage, 35 meters of interwoven steel, was meticulously lowered. Taller than a 10-story building, this intricate skeleton had to fit with mere centimeters to spare inside the 1,000-millimeter hole. Precision was not merely a preference, it was an absolute mandate. The concrete itself was then introduced from the bottom up using a specialized tremie pipe. Any deviation, any pour from the top would lead to segregation, destroying the pile's integrity entirely. An air pocket at that depth meant certain structural failure. Every single one of the 2,067 piles underwent a sonic integrity test. A sound wave sent down its length would reveal any flaw, any void. If the wave broke, the pile was condemned, rejected, and re-drilled. Representative piles were then subjected to load tests, pushed to 1.5 times their designed capacity. The ground barely yielded. Across a 48,000 square meter plot, the collective length of these subterranean anchors stretched for 50,000 meters. It was a monumental subterranean feat, a silent testament to human ingenuity. The very ground, once a fluid, empty sea, now held the promise of an impossible skyline, secured by a hidden forest of steel and concrete. The earth yields its secrets, but not without a fight. Each bore, meticulously drilled, leaves behind a meter of contaminated concrete, a slurry-laden cap that must be surgically removed. It is a necessary sacrifice, a cleansing ritual, preparing the ground for what comes next. From these purified depths, steel bars emerge, reaching skyward, destined to lock into the massive pile cap above. The very skeleton of the structure begins its ascent, connecting the bedrock to the heavens. Beneath this nascent structure lies an unseen forest of concrete, 50,000 meters of board pile, anchoring the colossal weight to come. This foundation alone contains more steel than many major bridges will ever utilize, a testament to the immense forces it is designed to withstand. The challenge was monumental: how to carve a cavern 10 meters deep into land reclaimed from the Arabian Gulf, a mere 5 years prior. The answer lay in a meticulously crafted subterranean defense, circantenating with softer, engineered cuts, fused together, creating a continuous, watertight wall. Where the structural loads demanded even greater resilience, a 1.5-meter thick diaphragm wall reinforced the perimeter, a solid shield against the relentless pressure. Yet, even with such formidable defenses, the Gulf remained a constant, unseen adversary. A single leak, a hairline fracture, possessed the power to destabilize the entire excavation phase. Under the crushing weight of Gulf water pressure, one crack could multiply, unraveling months of meticulous planning and construction. The response was immediate, precise. Expanding grout injected directly into the breach. A specialized foam designed to swell and seal, pushing back against the encroaching groundwater of the Gulf. Consider this: the dewatering pumps, the unsung heroes of this subterranean battle, ran non-stop for over 12 months straight, a continuous hum of defiance throughout the entire excavation. 10 meters of earth were removed from a sprawling 48,000 square meter footprint. That volume, an empty chasm carved from the earth, is larger than 20 Olympic swimming pools combined. Every single day, engineers meticulously measured the movement of the retaining walls. The margin for error was infinitesimal. Even a deflection of just 20 millimeters, less than an inch, would trigger an emergency stop, halting all work, signaling a potential catastrophe. This entire operation unfolded 10 meters below the surface of land that, just 5 years ago, lay submerged beneath the sea. The sheer audacity of it, breathtaking. Above this subterranean fortress, the pile cap emerges. Its purpose is fundamental: to collect the immense load from the columns above and distribute it evenly across the multitude of piles below. Before any reinforcement could be placed, an essential layer of blinding concrete was poured. It might seem a minor detail, but without it, the critical steel reinforcement would sit directly in contaminated mud, compromising its integrity from the very start. Ground beams then weave through the foundation, tying all the individual pile caps together. Without these crucial horizontal connectors, the piles, under the immense vertical loads of the tower, could splay outwards, leading to catastrophic structural failure. The process of vibrating fresh concrete is not merely a suggestion, it is an absolute imperative. Any oversight, any air pockets trapped within the concrete of a pile cap would inevitably lead to cracks under the crushing weight of the tower above. The unforgiving Qatari heat, often soaring to 45 degrees Celsius, presented another formidable challenge. Concrete cures too rapidly in such conditions, and cracking can begin within mere hours if it is not meticulously protected. From the pile caps, starter bars rise, the embryonic beginnings of the towering columns that will pierce the sky. The load path, a continuous line of force from the penthouse suite to the bedrock, begins its journey right here. Below ground, the structure plunges into 2 full basements, a subterranean world housing 3 levels of parking and all the complex mechanical plant necessary to sustain the colossal building above. Encasing this entire underground realm is a waterproof membrane, the basement's sole eternal protection from the relentless groundwater of the Gulf. One single mistake in its application and the consequences are permanent. The 400-millimeter thick basement slab itself is a marvel of engineering, designed to resist the powerful upward pressure exerted by the Gulf's groundwater. Without it, the basements would flood permanently, a constant reminder of the ocean's claim. The rebar within this slab forms 2 complete mats of steel, one at the top, one at the bottom, bound together by hundreds of intricate links. Its pouring was a 16-hour non-stop operation. Any interruption, any break in the flow that allowed the concrete to join in the wrong place would create a cold joint, a critical structural defect. Finally, the power floating of the slab's surface. This crucial step traps the rich cream of the concrete at the surface, creating a finish so dense and hard it can withstand the constant heavy traffic of forklifts and machinery, a testament to the enduring strength born from this relentless battle against the earth and the sea. Beneath the soaring aspirations of a modern marvel, an invisible battle rages. Here, in this singular critical zone, the very earth groan. A design crisis, silent but profound, threatened to unravel the entire endeavor before it even truly began. It was a moment of stark reckoning, where theoretical models collided with the unforgiving realities of physics. The solution was audacious, a testament to raw engineering might. Engineers responded with a decisive, almost defiant stroke. The structural slab, already robust, was augmented by an additional 400 millimeters of concrete, transforming it into a monolithic fortress. Simultaneously, the density of its internal steel skeleton, the rebar, was not merely increased, but doubled, a dense, interwoven mesh designed to defy the unimaginable pressures from above. Problem absorbed, not merely solved, but conquered by the relentless ingenuity of engineering. These colossal pillars, silent sentinels of the structure, bear the cumulative weight of 36 stories, a staggering vertical burden measured in thousands of tons. Each one is a testament to material science, forged from concrete boasting a formidable strength of 60 megapascals, a resilience few materials can match. Every single conduit, every precisely placed sleeve embedded within that massive slab was meticulously planned and mapped out 2 full years prior to its installation. A single miscalculation, a deviation of mere millimeters, could prove catastrophic. To miss one would mean a relentless, destructive core drilling through the very heart of the structural concrete, compromising its integrity. This is the realm where the true invisible engineering thrives. Basements, often unseen and uncelebrated, are the silent titans, bearing the foundational weight of everything that rises above them. This is the datum. Not merely a point, but the absolute zero, the primordial flat surface from which every single floor level across 36 stories is meticulously measured. A foundational truth, ensuring the perfect vertical alignment of a soaring ambition. The podium's ground floor itself is an architectural statement, soaring to a height of 6.1 meters, almost double that of a conventional story. This expansive volume is not just for aesthetic grandeur. It is engineered to accommodate and support the immense open span of the grand ballroom directly above it, a space designed for spectacle and congregation. Below, supporting the immense weight, are beams of colossal proportion. Each one plunges 4.8 meters deep, a structural behemoth taller than the ceiling of most residential apartments. These aren't merely supports. They are the critical arteries carrying the entire towering edifice that ascends from above them. Within these massive beams, the reinforcement is equally monumental. 40mm rebar, the largest standard diameter available, is not used singularly, but bundled in pairs. This extraordinary measure speaks volumes about the sheer, unyielding forces at play. Even the largest individual bar was deemed insufficient to bear the concentrated stress. Then, the unforeseen peril. C60 concrete, while possessing incredible strength, generates an immense amount of heat during its curing process, a chemical reaction so intense it can literally crack itself from the inside out. In a critical moment, the core temperature of a newly poured beam soared to 71 degrees Celsius. 71. A single degree above the absolute tolerance limit. The entire structural integrity of that colossal beam hung by a thread, threatened by an internal fracture that would have rendered it fatally flawed. In a race against time, an ingenious solution was deployed: chilled water, circulating through a meticulously laid network of pipes across the beam's surface. Slowly, agonizingly, the temperature began to recede, dropping back below the perilous 70-degree threshold, averting a potential catastrophe. Beneath this intricate dance of engineering lies the vast, cavernous expanse of the Qatari Hall. When complete, it will ascend to a breathtaking height of 22 meters. To create such an unimpeded volume, every surrounding column, every supporting element, had to be positioned with absolute, unwavering precision, a symphony of exactitude around a monumental void. Every single floor slab, seemingly a flat, featureless plane, conceals within its depths a labyrinthine network. Conduits for power and data, starter bars awaiting the next vertical pour, each component meticulously placed, a silent, intricate web of infrastructure. Once entombed in concrete, they are buried forever, their exact placement critical for the building's future functionality. For a time, a veritable forest of steel props, a temporary, shimmering canopy, bore the entire nascent weight of the tower above. Below, the colossal transfer beams, still nascent, slowly gained their formidable strength. Then, the moment of truth arrived. A delicate, calculated operation unfolded. One by one, with painstaking precision, each prop was systematically removed. Simultaneously, sensitive instruments meticulously measured the imperceptible bending of the newly strengthened beams. It was a controlled, gradual transfer of immense load, a careful ballet of physics, until at last the podium stood solid, self-supporting, a foundation now ready to truly bear its burden. With the podium stabilized, the stage was set. 8 core wall locations were precisely established, marking the true commencement of the vertical ascent. These 8 reinforced concrete cores are more than mere structures. They are the very spine of the building, the central nervous system from which every other element, the sprawling floors, the elegant facade, the intricate mechanical, electrical, and plumbing systems will ultimately suspend. One of these cores employs the SKE-50 climbing system, a marvel of automated engineering. Hydraulic rams with silent, immense power push the entire self-contained platform upwards, using the very wall it constructs as its track. Within this enclosed protective climbing box, shielded from the elements and the dizzying heights, skilled workers meticulously place thousands of steel bars during each rapid cycle. There is no reliance on external crane picks for formwork, no open exposure to the dangers of the sky, just relentless, efficient ascent. In contrast, walls 3 and 4 utilize the crane-lifted 150F system. While each new position demands a precise, deliberate crane pick, a method inherently slower, it offers an unparalleled level of accuracy, a meticulous dance between man and machine high above the city. At this incredible pace, a vertical climb of 4.45 meters can be achieved in just 2 hours. A single floor cycle completed. The cores, the very backbone of the tower, are ascending with a speed that defies initial projections, pushing the boundaries of construction efficiency. The tower's distinctive, elegant curve introduces an additional layer of complexity. With every successive floor, the angle of the formwork face must subtly, yet critically change. To achieve this architectural grace, ingenious wedge panels are employed, precisely compensating for the lean, ensuring the integrity of the curve and the flawless progression of the facade. From the unseen depths of its foundation, through a symphony of calculated risks and brilliant solutions, this structure rises. A testament not just to steel and concrete, but to the invisible ingenuity, that shapes the very skyline. The very heart of a skyscraper, its core wall, demands a sequence of operations so precise it borders on ritual. Pouring concrete too quickly invites catastrophe, a violent rupture as the immense hydrostatic pressure of the liquid stone overwhelms the formwork, sending tons of material cascading downward. This is not merely a theoretical risk, it is a fundamental challenge that dictates the rhythm of construction, a constant dance on the edge of structural integrity. As the vertical ascent continues, floor by floor, the pressure exerted by the colossal weight of concrete at the base of the formwork escalates exponentially. The solution, born of rigorous engineering and hard-won experience, is counterintuitive. Slow the core rate. Instead of a meter per hour, the pace drops to half a meter, an agonizing deceleration that doubles the pour time for each section. This deliberate, measured approach is the only safeguard against a catastrophic failure. High above the city, a symphony of progress unfolds as all 8 cores climb simultaneously. 4 ascend with the silent efficiency of automatic systems, while the other 4 are painstakingly lifted by towering cranes, their movements a delicate ballet against the sky. Each core, a unique column in this emerging giant, reaches a different height, creating a dynamic, ever-shifting landscape of concrete and steel. It is a spectacle of controlled chaos, a testament to meticulous planning orchestrating immense power. By the time the structure reaches floor 18, a subtle yet profound transformation begins to manifest. The cores, once strictly vertical, now betray a deliberate engineered lean. What began as an abstract curve on an architect's blueprint is now taking tangible form in solid concrete. Before every single pour, a team of dedicated surveyors meticulously measures and verifies the wall's exact position, ensuring every millimeter aligns with the grand design. Their work is an invisible thread of precision, weaving the architect's vision into reality. Within the nascent core, a temporary staircase, itself a marvel of modular construction, serves as the sole artery to the advancing frontier of the build. It is assembled floor by floor, a lifeline ascending in tandem with the concrete, offering a dizzying perspective on the scale of the undertaking. From the side, the building's true character begins to emerge, the dramatic curvature of its walls revealing the unmistakable silhouette of a colossal sword rising from the earth. This is no ordinary vertical ascent. The walls lean outward, gaining an imperceptible yet intentional tilt with every floor poured, a bold architectural statement etched in stone. The unforgiving climate of Qatar's, with its scorching 45-degree days, presents another formidable challenge. Such extreme heat can severely impede the proper curing of concrete, compromising its strength and durability. The ingenious solution: night pours. Under the cooler cloak of darkness, the concrete can set properly and achieve its optimal strength more quickly, a relentless pursuit of the schedule that continues long after the sun dips below the horizon. Reaching floor 30, the majestic shape is now undeniable, etched against the vast expanse of the sky. What was once a subtle hint has become a definitive declaration. 2 magnificent swords, cast in concrete and glass, now dominate the urban panorama. While the cores relentlessly climb skyward, the floor slabs chase them from below, a dynamic interplay between 2 distinct construction fronts converging to form a single, unified structure. This intricate choreography demands innovation at every turn. Consider the Docker flex table, an engineering marvel that unfolds with the deceptive ease of a piece of furniture. Yet, this seemingly simple mechanism is designed to bear an astonishing load: 400 kilograms per square meter of wet concrete, a testament to its robust design. The sheer complexity of the building's design, where every single floor boasts a unique shape, a staggering 36 distinct plans, threaten to derail the entire formwork schedule. This unprecedented challenge demanded an equally audacious solution. Docker rose to the occasion, manufacturing an astounding 10,000 square meters of custom tables, a bespoke set for each individual floor, no two identical. This monumental effort of custom fabrication was the only way to translate such a complex vision into reality. Further accelerating the pace, the innovative TLS system allows these massive tables to be raised 2 floors in a single fluid motion, entirely independent of the crane. This ingenious autonomy doubled the speed of the entire slab program, a critical breakthrough that kept the ambitious timeline on track. The sweeping curve of the building dictates another intriguing consequence. Every balcony on this structure extends further outward than the one directly below it, creating a mesmerizing, cascading effect that is both visually striking and structurally complex. Long before a single drop of concrete was poured, every pipe, every cable, every duct destined to pass through these slabs was meticulously designed and precisely positioned 2 years in advance. There is no room for error. Once the concrete sets, the design is immutable. 40 meters above the podium, the view is a dizzying spectacle of raw power and exposed ambition. There are no finished walls here yet, only the skeletal framework of rebar and newly poured concrete, a stark landscape of engineering prowess. From this precipitous height, the sensation is truly terrifying, a visceral reminder of the immense forces at play. At the heart of this colossal operation, a powerful pump relentlessly pushes 90 cubic meters of concrete per hour. To put that into perspective, it delivers the weight of a fully loaded double-decker bus in concrete every 10 minutes, a continuous, thrumming testament to raw power and efficiency. In this realm of precision, floor flatness is not merely desirable, it is absolutely critical. Even a minor deviation, a barely perceptible warp in a floor slab, can trigger a catastrophic chain reaction. Partitions will not fit, walls will fail to close, and tiles will inevitably crack. Such imperfections are utterly unacceptable. To ensure absolute perfection, a thermal drone meticulously surveys every single 1,200 square meter freshly poured slab, searching for any telltale hotspots that might indicate uneven curing. This vigilance is absolute, a relentless scrutiny applied to every floor, without exception. For the expansive, open-plan ballroom floor, a specialized technique known as post-tensioning is employed. This advanced method involves embedding high-strength steel cables within the concrete, which are then tensioned after the concrete has set, creating a compressive force that significantly enhances the slab's strength and allows for vast, unsupported spans. From the delicate balance of hydrostatic pressure to the relentless pursuit of millimeter-perfect flatness, every aspect of this colossal endeavor is a testament to human ingenuity and uncompromising precision. It is the transformation of an impossible vision, a curved sword of steel and concrete, into a breathtaking reality. Steel tendons, an invisible network of immense strength, are threaded through the freshly poured concrete slab. Once the pour is complete, these sinews of steel are pulled taut, each one locking in a staggering 186 kilonewtons of force. That is the equivalent of 19 tons of compression, an unseen battle against gravity, meticulously engineered to prevent any hint of sag, any whisper of weakness in the vast expanse of the floor plate. Floor by floor, the building's wings begin their ascent, stretching outwards into the sky. A magnificent crescent shape emerges, each successive slab extending the tower's footprint, pushing the boundaries of its silhouette. Every single floor beam, a unique arc in this architectural symphony, possesses a different curve radius. These intricate components are precisely cut by computer numerical control machines in a distant factory, each one an exact match to the three-dimensional blueprint of the building information model. High above the ground, 50 meters into the open air, a 12-ton steel beam swings precariously in the wind. Below, the ironworkers, a testament to raw human skill and unwavering courage, stand ready. With nothing but their honed muscle and the leverage of a spud bar, they guide the colossal mass into its precise position. In this crucible of construction, the curved steel beam and the reinforced concrete column become more than just connected parts. They fuse into a singular, cohesive structural system. Shear studs, tiny yet mighty connectors, ensure the steel beam and the concrete slab work in perfect tandem, forming a composite section that doubles the bending strength, an elegant solution to the immense stresses this structure will endure. The true marvel, the audacious secret of this colossal undertaking, lies in a counterintuitive truth. Construction accelerates as the tower climbs higher. The intricate system, once a complex choreography of discrete tasks, has become fully optimized. A rhythm has been found, a precision perfected, allowing the pace to quicken with each ascending level. Yet, a subtle challenge persists. The tower, by design, leans. This deliberate tilt means the colossal weight of the structure does not bear down centrally on its columns. To counteract the bending forces this creates, an embedded steel core, a hidden spine of immense rigidity, stands ready, silently resisting the immense pressures. On floor 36, the core wall pour represents a monumental milestone. This is the very last lift of concrete for the structural spine, the final act of vertical ascent for the building's central support. The cores have topped out, reaching their maximum elevation. That roof slab now stands an astonishing 246 meters above the ancient bedrock below, a dizzying vertical distance from the bottom pile to the very apex. The final concrete pour on the roof of this 211-meter tower was an 18-hour odyssey. It unfolded in the profound darkness, high above the shimmering expanse of the Persian Gulf, a solitary beacon against the vast, inky canvas of the night sky. 211 meters above the Gulf, the structural cores had indeed reached their zenith. But the engineering challenge, the relentless pursuit of perfection, was far from over. Below, a symphony of precision was still playing out. The final survey delivered an extraordinary verdict. Every single core wall, spanning a vertical distance of 211 meters, was within a mere 8 millimeters of its theoretical position. This level of accuracy, a testament to meticulous planning and flawless execution, is nothing short of breathtaking. Then there is the facade, a shimmering skin of glass and metal comprised of 5,000 individual panels. Not a single one is identical. Each panel is a unique creation, engineered and manufactured individually to fit its precise place in the tower's sweeping curves. Glass, heated to 650 degrees Celsius, is coaxed into its specific curvature, a delicate dance of fire and form. Every panel is destined for one specific position on the tower's intricate facade. Beneath the surface, a specialized laminate known as sentry glass binds the shattered fragments together under impact, offering a resilience 5 times greater than standard laminates. Even the aluminium framing, the skeletal structure holding the glass, is curved, precisely bent by computer numerical control machines to match each floor level's unique arc radius. There are no straight profiles here, only flowing lines, a liquid geometry. On a project relentlessly driven by the looming deadline of the 2022 World Cup, a single logistical error, a momentary misstep in a complex chain, cost 4 hours and an entire crane shift. Such is the unforgiving nature of a venture of this scale. To prevent further delays, every panel, from the moment it leaves the factory, is meticulously tagged with GPS data. The crane operator, miles above the ground, sees the exact floor and position displayed before each lift, transforming a monumental task into a seamless, guided operation. Each panel clicks into a precast bracket embedded in the slab edge, a seemingly simple connection that belies its sophisticated design. This connection allows for the subtle thermal movement of the building and accommodates the imperceptible seismic drift, ensuring the facade remains robust and resilient through all conditions. Is no on-site glazing, no complex assembly high in the air. It is a process of elegant efficiency. Simply click, seal, and move on to the next. Before any section of the facade is officially accepted, every single bay undergoes a rigorous water test, a final confirmation that this shimmering skin will stand as an impenetrable barrier, a testament to unwavering precision and the triumph of human ingenuity against the forces of nature. A single, almost imperceptible leak, hidden within the labyrinthine network spanning 36 floors. Its discovery was a testament to relentless scrutiny, its repair a triumph of precision. For a structure of this immense scale, one flaw could compromise everything. Now, the final facade panels ascend, locking into place across the uppermost 3 levels. Slowly, deliberately, the protective netting begins its descent. With each foot it yields, a monumental edifice emerges, shedding its temporary shroud. For the first time, the entire building stands revealed, its sleek lines unobstructed, a new titan upon the skyline. Deep within its core, 4 colossal centrifugal chillers stand ready. Their combined might delivers an astonishing 8,000 refrigeration tons, a cooling capacity vast enough to command the climate of an entire district. Each pipe, each connection faced an unforgiving 16-bar pressure test, lasting a full hour. The slightest drop in pressure would betray a hidden vulnerability, a silent threat lurking within a riser shaft wall, demanding immediate, meticulous investigation. Efficiency is paramount. Every turn in the vast ductwork network inherently diminishes air pressure, a constant battle against entropy. To counter this, the entire layout was optimized by advanced computer models, minimizing every single bend, ensuring peak performance and minimal energy expenditure. In the grand ballroom, an invisible intelligence observes. Carbon dioxide sensors embedded in the ceiling react to occupancy, seamlessly adjusting ventilation. More guests mean more fresh air, automatically, continuously, without human intervention. Then came the moment of truth. 33,000 volts of raw power surged into the building for the very first time. Every engineer, every technician held their breath in that charged silence, a collective anticipation hanging heavy in the air. This was the pulse of the new city within a city brought to life. Safety demands absolute certainty. 36 floors underwent rigorous sprinkler testing, every single head activated, every alarm triggered. There is no second chance when lives are at stake, no margin for error in a fire suppression system. Finally, the last commissioning certificate was signed. Every system within this 211-meter hotel, from climate control to fire safety, from power distribution to intelligent ventilation, was tested, certified, and declared ready. The journey from audacious vision to tangible reality, from a single blueprint to a perfectly functioning, living structure, was complete. The meticulous hunt for that single hidden leak had culminated in an edifice of unwavering perfection.